right, ladies and gentlemen, Gibbs free energy. Mr. Gibbs was quite a clever gent, and he combined the enthalpy of a reaction and the entropy of the reaction in an equation that looks somewhat like this, that is dependent on temperature, that is the absolute final answer as to whether a reaction will be spontaneous or not. Gibbs free energy is defined as the energy available to do work and the energy that's available to do work is based on the enthalpy, the heat content of the reaction, minus the temperature in Kelvin times the entropy of the reaction. If delta G is a negative value, it will be a spontaneous process. Now, remember, spontaneous means that it occurs without any outside intervention. All right. So, I just want to remind you really quickly, this is in kilojoules per mole.
Are we using Celsius or Kelvin?
Kelvin. This is in kilojoules per mole. This is in Kelvin. Careful, this is in joules per mole from your standard table. You must, when you are using this reaction, have all units correspond. What I do is just change the delta S to kilojoules, and everything is wonderful. Okay, thank you. Don't go in front of the camera, okay? Now remember, if you see the little ot sign, that means it's at standard conditions, room temperature, 1 molar concentration, and 1 atm. Okay, let's consider this reaction. I have 2 SO2s plus an O2 yielding 2 SO3 gases. I calculate the delta H, the delta S, and the delta G using the following information. And the following information is really tiny. Now it's really blurry. Now it's fine. Let's do this. All right, remember that delta H and delta S are both state functions. So it's products minus reactant. Guess what delta G is? State function. So it is products minus reactants as well. Whenever it says. Yeah, go now. Oh, I don't know that. Where do you go for your senior conference? Counselors? Okay, library. Don't go in front of the camera. Okay, might say in there. So here we go. Hey, we don't even have a value for delta G. How else can we figure out delta G? Yep, delta H minus the quantity, temperature, delta S. All right, apparently that's where they're leading. But before we can do that, we need to find delta S and delta H. So delta H is products minus reactants. And here we go. We have 2 times SO3, which is minus 396, minus, that's the products, minus the reactants. And our first reactant is the SO2. There are 2 of them, so it's 2 times minus 297, plus the value of the oxygen. Remember that oxygen is 0 because it's an element.
Enthalpy is the weird one that is products.
That is not correct. It's products minus reactants.
No, which one is the weird one?
The bond energy. When you do your math, you're going to come out with a negative 198 kilojoules per mole. That on its own says that it's probably a spontaneous or non-spontaneous? Spontaneous. But we can't be sure because we also have to figure out entropy, because entropy plays a part in this too. So the entropy will be the products minus the reactants as well. SO3 is 257 minus the SO2, which is 248, and there's two of those, plus the value for oxygen. We recall that there are entropy values for elements. This one is 205. There's only one oxygen in our reaction. So when we do our math here, delta S has a value of negative 187 joules per K. Now, does this make sense to us, given this reaction as far as delta S goes? Because we have 3 moles of gaseous reactants and 1 mole or 2 moles of gaseous product. That is a decrease in entropy, so the negative sign is a valid result. We're going to say delta G is equal to delta H minus this quantity. Right this moment in time, before we forget, let's change delta S to a compatible unit. That would be negative 0.187 kilojoules per mole. And now we're ready to figure out delta G. That's equal to minus 198 minus the quantity 25 degrees Celsius is 298 K times a negative 0.187. And I have no idea what it is. Negative 142 kilojoules per mole. How many people can corroborate this answer? You got that as well? Okay. Thank you very much. Is this spontaneous or non-spontaneous? It is spontaneous. So the delta H is predicted to, predicts this reaction to be spontaneous. The delta S predicts this to be non-spontaneous. However, at this temperature, the delta G is negative, so therefore it is a spontaneous process. Remember, predictors of spontaneity, delta H is a negative, delta S is a positive, generally spontaneous. Delta G is negative, always spontaneous. Okay. I got ahead of myself. And now is the time I would like to tell you that delta G is a state function like delta H and delta S. That means it's the sum of the products minus the sum of the reactants. I would like to point out to you again that the delta G values for elements are 0. So if you are highlighting stuff to remember for the quiz, you should remember delta G and delta H elements have 0 values. Delta S has a value for elements. Okay. It says find the free energy of formation, that is code for Gibbs free energy, for the oxidation of water to produce hydrogen peroxide. Water plus O2 yields 2H2O2. given the following information. Here are the standard Gibbs free energy of formation of H2O, oxygen, and H2O2. So we recall it's products minus reactants. So 2 times H2O2, negative 27.2, minus the reactants, 2 times negative 56.7, plus 0, yields a delta G value of 59 kilojoules per mole. Spontaneous or non-spontaneous?
Non-spontaneous.
Non-spontaneous, is that a good thing?
Water,
Yeah.
the epsilon.
Yeah, we got water all over the place, folks. We got oxygen all over the place. We do not want them forming H2O2. We need our water to stay
Oh, yeah.
water. And I like oxygen.
Miss Miss Adams.
Mhm.
What does the epsilon stand for?
The sum of.
Sum of.
Okay. All right. The third way you can find the value of Gibbs free energy is using a Hess's law situation as well. Okay. So here is our target reaction, and we are going to see if indeed diamonds are forever. Diamond will spontaneously go to graphite or not. Huh? You hope it doesn't?
It's not much of a long-term investment.
Then it would not be a long-term investment. Okay, here we go. Here are our elementary reactions. We're trying to get
What is gold's half-life? How long does it
gold
stay?
doesn't have a half-life.
How long does it stay gold?
I don't know, forever.
It's an element.
It's an element, it cannot be broken down further, so a really long time. Okay, here we go. We look at this and say diamond is reacted here, a reactant there. Let's keep this as written. Therefore, the delta G value will be as written too. Now, this has graphite as a reactant. We would like it as a product, so we will go ahead and reverse this one. That means we have graphite plus O2, and so we're going to flip the value of delta G. We're ready to add our terms. O2 cancels, O2 cancels, CO2 cancels. We have a diamond going to graphite. And guess what? Delta G is a negative value, so it turns out that diamonds are not forever. Your diamonds are becoming graphite. Gentlemen, I would use this at some future time to tell someone, baby, I didn't get you a diamond because you know what? They're not even forever.
Isn't that a negative 3?
Yes, negative 3.
What is the number of?
This is the examples in the book. What?
Also, I think it's.
No, negative 3. Okay, my math skills are mad, aren't they? 397, negative 397 plus 394, and I get 4. Sheepers. Okay, now, one more time, just for fun.
Hang on, can you go back up a little?
Just for fun, if a delta G is positive, the reaction is not spontaneous. If the delta G is negative, the reaction is spontaneous. What I need you to do now is be able to manipulate this chart all the time. All right, this is how I want you to figure this out. First of all, maybe we need a little math moment here. This is what we're going for, right? Okay. Now, if we have a negative value of delta H and a positive value for this quantity, which would be a positive entropy because you can't have negative temperature, right? A positive value. And you do some subtracting here. It's like doing what? Adding a negative.
Shouldn't
Everybody
KJ
is good there?
Shouldn't it be KJ per mole there?
You can, yes, you can write them all. That's the same thing. Okay, we all good there? Okay. If we have a negative value for delta H, and we have a negative entropy, which makes this entire quantity negative, that would be like negative plus a positive. Is that correct?
Yes.
Okay. So we're good there? All right, now if we have positive here and we have positive here, that's like adding a negative. Okay, we got this. We'll need that in a moment. All right, now we're going to use our math skills to discover at what point this value of temperature is going to make delta G a positive or a negative number. With me now? Okay, so delta G will be a negative number, therefore spontaneous, anytime that delta H is a negative number and delta S is a positive number. Because what you're doing is adding two negative values together. So delta G can be nothing except negative. Good there? Okay. Now, let us take the one other situation I never did. Okay, when delta H is positive and delta S is negative, that would be the same as taking a positive number and adding a positive number. Is that correct? Okay. So when delta H is any value that's positive and delta S is any value that's negative, there's no way you can get a delta G value that's a negative number. It's always a positive number. Do you see that? Okay. Now, here are the two scenarios that depend on the temperature. If we have a positive delta H and a positive delta S, it depends on the value, the magnitude of this part of the equation as to whether delta G will be a positive or a negative number. Do you get that? So, high temperatures, delta G will be negative. Low temperatures, it will not be negative. Likewise, when I have these two, delta H and delta S are negative numbers, it again depends on the value of the temperature, whether or not delta G will be negative or not. It is spontaneous, or I will have a negative value of delta G at low temperatures. Now, you can go through and reason these out as I've done. Or you can do what helped me out when I was doing this as a beginner and do this. All right, so, and I'm using positive and negative signs. So if delta H is a negative, delta S is positive, it will always be spontaneous. If delta H is positive and delta S is positive, only at high temp. If delta H is negative, delta S is negative, only at low temp. If delta H is positive, delta S is negative, never spontaneous.
When you say high temp, you mean
Higher than absolute zero.
what?
You'll just have to put it into the numbers to see. Every situation will be different. Okay? Now, how are you going to remember this? A positive number
but what I meant was like.
Okay, hang on for a minute. A positive number is big. So at big temps, it's spontaneous. Get it? Positive, positive, make your temp big positive, spontaneous. Negative, negative, negative numbers are little. So at low temp, little, it's spontaneous. Is that helpful at all?
Yes.
Okay.
What I'm-
Are you good? Okay, this will be a situation I promise you will see over and over and over again. In an essay question, you have to be able to mathematically prove this. If you forget this, try numbers. Try high temp and a low temp and see what happens. Remember, it's always a Kelvin temperature. Always a Kelvin temperature. And the AP folks, don't